Hello everyone, and welcome back to Revit Snippets. Great tips you can learn in just a few minutes. This video is brought to you by Tagitize, the easiest way to run tag all on multiple Revit views and sheets. Also, say goodbye to overlapping tags. Tagitize will turn this into this. Try Tagitize completely for free using the link in this video's description.
Are you struggling with a large number of orphaned room tags in your model? I used to have this problem after tagging some rooms in Revit, and then these rooms were replaced inside that link. That caused the room tags in my model to lose their hosts and just showed as question marks. It used to take me so much time to select each orphan tag, click pick new host, and then select the link room to rehost the tag to that room. What's annoying is that the tag's location is still correct, but the room right under it has changed, so now I risk having to do all that label work again. Luckily, I have this small Dynamo script here to save me this time. Let me run this now so you see the magic. There we go. The script has automatically rehosted all my orphan room tags based on their locations. Each tag has been reassociated with the linked room closest to it. Isn't that great? If you don't have much time and just want to run this script right away, simply find in the video's description a link to download this script directly. If you, however, want to learn to code this yourself, let me show you how right now, step by step. By the way, if you are new to this channel, make sure to subscribe now because we do tutorials like this every single week. Alright, let's get started. Let's create a new script in Dynamo. I will now add a Python node to the graph and open it for editing. However, this is not a good script editor, so I'll type the code out in Visual Studio Code instead and copy it back into Dynamo at the end. If you're new to this workflow, don't worry. Just find in the video's description below a link to my other tutorial on how to set up this coding environment. It will also provide you with this Python template for Dynamo. That will give you all the necessary information to then return to this video and start scripting with me. To begin, let's define two lists to report the result of running this script. I'll call this done and skipped. We will soon add room tags to this list depending on whether they have been successfully rehosted or ignored. Next, let's collect the Revit link instance from the first input port of this Python node. Once I have the link, I can get its document and also its total transform. Let's invert this transform. I'll show you why in a minute. Moving on, it's time to get the active view of the model like this. Note that the active view can be a floor plan, section, elevation, and so on. For this, we need the view to be a floor plan. So let's add a check like this. If the view is of an unsupported type, I'll exit the script early with a helpful message. That should guide the user to try the script again on a floor plan view. Once we have the view, let's query its elevation like this. We'll soon make good use of this value. Next, let's create a new list to store ID values of tags we will delete. This is because it's actually not possible yet in the Revit API to rehost a tag. Therefore, we'll recreate each tag with the correct linked host and then delete the old tag. These ID lists will help us with the deletion part. Alright, with all that set up in place, let's start modifying the model. To start, I'll add this statement to make sure any opening transactions in the model are closed. Next, I'll start a new transaction like this. At this point, I can start iterating over all room tags in the view using an element collector. For each tag, let's check if it's a family instance. If that's true, we'll skip it because it's not a standard tag. The next check is to see if the tag is orphaned. If not, we'll of course skip it because it's already good to go. Now it gets more interesting. We'll get the tag's placement point like this. Then let's move it up by 1 unit along the z-vector. This new point would be more likely to be inside the linked room instead of being trapped in the room's floor or finished floor. Next, I'll apply the link's inverse transform to the point to move it to the local coordinate system of the Revit link. Without this step, room detection may not work. To detect the link room at this text location, let's look through all phases in the link like this. For each phase, we'll call this method to find the link room at the point's location that was created on that phase. If such a room exists, we can break out of the loop like this. On the other hand, if no room is found after checking all linked phases, we can't recreate the tag. In that case, let's add this tag to the skipped list and then continue checking the next tag. If there's a valid link room, we can finally create a new tag in the location of the existing one. Note that this new tag will use the default room tag type in the model. Therefore, the next step is to change its type to match the family type of the existing tag like this. Once that's done, I can add this new tag to the done list. Then I'll add the ID of the existing tag to the list of ID values to delete. Once we have finished checking all existing tags, it's time to clean up the tags we have successfully replaced. To do that, I'll first check if the list of ID values is empty. If not, I'll call the delete command like this to delete those tags. Finally, let's not forget to commit the transaction like this, and then add the done and skip list to the output of the Python node. With that, our Python node is now complete. Next, let's copy all text from this file, paste it into the Python node in Dynamo, save it, and close this node. We also need to add a node now to select the Revit link that contains rooms. I'll pick it now from my view and then feed this input to the Python node. Last but not least, I'll change the Python version here from version 3 to version 2. This is because my Python script in Visual Studio Code was written in this lower version. With that, our Dynamo script is finally complete. Let's now run the script to see it in action. Alright, it has worked beautifully just like before. However, you may notice that these room tags overlap many other elements in the view. This is because these were placed at the room's location points without considering other existing objects. If you want a better tag layout, try using Tagitize. If I just quickly delete these tags and then run Tagitize, it will intelligently consider all visible elements in the view to give me the best tagging result. There we go. These room tags now have much better locations, away from any objects that previously overlapped the tags. Even better, you can use Tagitize for any Revit category, not just rooms. If I tell it now to tag also furniture and special the equipment. Let's see what it will give us. It had to arrange a lot more tags this time, but it did so very well. All my tags are perfectly readable, none of them overlaps with their hosts or other elements in the view. If I think this tag, for example, can be placed better, I can just select it and click next to tell Tagitize to try the next possible tag position. There we go. That's much better.
If you want to try Tagitize, simply use the link in this video's description to try it completely for free.
There is also a link in the description to download the script we built together today. Even more, if you want to master Python scripting in Dynamo to create this kind of script yourself, check out my full online Python for Dynamo course, also linked to in the video description.
If you like this lesson and want more like this every single week, make sure to subscribe to this channel now. For now, have a good day and I'll see you in the next tutorial.